This one's going to be a kinematic sketch for a ball pickup based on 2014. So once again, first thing you want to do is when you put in your knowns, the things that will never change. I'm going to put the ground in. I'm going to put I'm going to create a construction line. So if you click on this button, it goes to construction mode. I'm going to put a rectangle in here. Requirement says you have to be under 60 inches. Let me put a constraint into the center. And this year you want to be as low to the ground as you could. The floor was the floor was smooth, not pretty smooth. It was smooth. So I'm going to constrain the center of the edge to the center of the origin. Frame perimeter was called to be less than 112 inches. So I'm inclined to go 28 wide or 26 wide and 30 long. So I'm going to come in and set this to 30 inches. So we need to stay inside of this envelope when we're creating it. We want to create something that will actually come down and grab a ball. So the ball is 2 foot in diameter. That's another known, right? That will not change. Creating a tangent. We have no idea how far away it's going to be, and we'll put some mechanism in. And we're going to set the ball to be 2 foot in diameter, 24 inches. So that gives you an idea of the scale. There are a number of teams that made ball pickups, but it has to start within the frame perimeter. I'm going to come in, I'm going to create a pivot point, and we'll assume the pivot point's dead center on the robot. Doesn't matter what size this is. Let me come in and say it's like 3/4 inch. Let's put a dimension from the ground up. We don't want to be too high, so my guess would be like 27 inches off the ground. Alright, now let's create a mechanism that will swing down and grab the ball and then come back up and maybe flip over top dead center. So I'm going to use a slot and use the center of the actually I'm going to come back. I'm going to go out of construction mode. Alt C that out. I'm picking an arbitrary angle. Let's say this bar is like 4 inches in diameter, and off of here I'm going to create a dimension off of here, aligned. Guess 24 inches. Now you can see this spins down, and you can also see that I didn't get the end of it constrained over the center. So I'm going to constrain the center of the bar of the origin. And now if this spins up, sometimes it gets a little finicky. the bar is straight up in the air, but then this comes straight down. Actually, it looks a little bit long for what we need to do. Come back and put it at 20. 18 may do it. Now I'm going to create a rectangle. Get the center point of the rectangle directly into the end of the slot. And set the edge of the bar to be perpendicular. Put a dimension on the face. And it's going to be probably greater than 2. Well, I would say greater than 2 foot, but we're grabbing not in the center of the ball, but out towards the edges. 18 is probably fine. So here's the bottom piece. The ball is 2 foot in diameter, so let's come out like 15 inches. And set this. Inch and a quarter diameter. By the way, if we grab this, the whole thing should move now. Also be handy to know what size diameter we're going to grab at. So let's create a sketch down here, or create a circle down here to simulate where we're going to grab on the ball. And this is only for layout purposes only. In fact, let's put 2 circles in there. The 2 rods will come down and grab the bottom. And we said the rods were 1 1/4 inches. We'll set these to be horizontal to each other and then tangent to the circle. And directly above this will be the rollers. What do you think? What do you think the roller diameter ought to be? We set the center of the ball the origin, by the way. By the way, the ball is 2 foot in diameter. I don't know, seems to me maybe a 4-inch diameter wheel. And the wheel would be 1 inch wide. And we set these on the same level. I'm going to try to grab, so we haven't set the width that we're going to be touching at, but we can come in now and those are kind of the wheels. reason we want this is it shows we're going to take this view, which is looking at the forks coming down the touch. Let's say it's 18 inches. So now we know in between the top rail and the bottom rail, this is going to complain right now. It's going to say that we already know this. It's a reference dimension. So from the post to the center of the tube is 19.32. So I'm going to create the 4-inch wheel up here. Come in and grab do the rectangle. And the center of this roller should be in line with the center of. I have to be careful right here because if I do this, it's going to. The sketch will degrade. So I'm purposely doing some things. So let's put the end of this in line with the grabbing piece, and let's also set the length here. Actually, I probably don't even need that dimension. I can come in and make them equal lengths. Right? And now from center to center, in fact, I really like to get rid of that dimension. Although we don't have a point right here. If we go from edge to edge, it's equivalent from center to center since they're the same diameter. If we set this to 19.32, and we're grabbing at let's put a dimension in between this line. Be nice to put a point in there. I put a point in, and then I'm going to tie the point to the circle, and it didn't jump. Point to the circle, and then the point to the other circle. So let's go in between this point. This can also give us another reference dimension. So 16.881. So I'm going to create a construction circle here to simulate. .881. Really, this is going to let's find and break the constraint. There's the tangent constraint right there. We get rid of that. What's the easiest way of doing this? I'm going to put a construction line in between the center of from center to center, and then I'm going to tie the center of the ball to the center of that point. Now when I grab the arm and move it up and down, this is really getting it's having trouble solving on it. I'm going to come in and put a vertical line in here to reference from. But you can see the sketch moves, so we'll just come in and put an angle in. So let's come down to 45. Moves a little bit slower. The ball's into the ground. Let's go 55. Nope, 60. Now that looks like we'll clear the bumper. This ball's still inside of the ground. There you go, ball's at the ground. So this looks like it will clear the bumper. Also going to put a dimension here because that was never defined. Everything goes blue, right? And I'm going to set this at like 1.5. Pretty close. So now you'll see that we can reach down. We're clearing it, getting over the top of the bumper. Then when we set this to 90, you can see we're lifting up. 120. 150. Now the question is, will we be inside the frame perimeter? 180. And no, we're not. We're above the requirement of 60. So looks like we have some clearance in between the ball. Oops. Let's go back into the sketch. We have some clearance in between the ball and the end, so we could pull this back, let's say to 13.5. Wheel's still outside the frame perimeter. I have the feeling the 18 needs to stay where it is, so let's come down and come down to 25 inches for our pivot. Wheel's now inside the 18, so we could start with the ball straight in the air, come down, we're reaching, ball's on the floor, pretty close to the floor, ball's at the floor. Looks like we could clear the bumper, so we've got a clear shot to pick the ball up and lift up. The ball will probably come past center here and come up against the stop in the inside, and we'd have to build a shooter mechanism or a spring release puncher in here. So in 18 minutes, got a sketch on doing a two-wheel, two-prong ball and large ball intake. Hope this helps.